So this is number 9 in our review for chapter 7, where we're given those probabilities and we're asked to determine the probability of the complement of y, which basically means not y. And I think that for this problem it might be easiest for us to make a little Venn diagram. So if I label this circle in my Venn diagram event X, and I label this circle in my Venn diagram event Y, then I know the probability that it is in both X and Y is equal to 0.12. And so I always put the intersection probability in a Venn diagram first. And then using the fact that the probability that it's in X is 0.23, then I already know that in my X circle I already have 0.12, so what must be in just X must be 0.23 minus the 0.12 I already have in that circle. So there's 0.11 that is just in X. Then another fact that I'm given is that the probability of X or Y is 0.34. That means all of the numbers within the circles X and Y must add up to 0.34. Well, the numbers I already have add up to 0.23, so that means the probability that it's just in Y would be equal to whatever I have when I take 0.34 minus 0.23. So just in Y is also, in this case, going to be 0.11. And just a note, just in X and just in Y aren't always the same. But notice now the numbers inside of my circles in my Venn diagram do add up to 0.34. So that means that the probability that it's not in X nor in Y must be 1 minus that 0.34, and that would be 0.66. So this out here is 0.66. So now all my probabilities add up to 1. So now to my question. What is the probability that it's not in Y? Well, the numbers or probabilities that are not in Y would be this 0.11 and this 0.66. The 0.12 and the other 0.11 are in Y, so they are not a part of the complement of Y. So to answer this question, we just take those two probabilities, 0.11 and 0.66, and add them to get the probability that they're not in Y.